I don't know, kind of throwing me off the cliff when I read like all, like 10 pages, but it's all like 8 questions.
Mm. Well, that's why we are having a practice exam today, so that we can talk about it a little bit and see if that will help. But I will probably not have a lab after the exam on Wednesday. But not because you guys said that you don't want one. Let me make it very clear. It is not because of that. Yes, I do not give in to requests or demands or
Uh,
votes, that sort of stuff.
no, no, I completely understand it. And then, and I have a second question. It's kind of like about the grade wise.
Hmm.
I look at the syllabus, like on the first day. I
Yeah.
know, I'm sorry, I'm too late to ask that question. I should have been asked on the first day. I do apologize for that. Um, I see like how the way you grading, and it was like show like 37.5. I believe that was the passing grade. So like for example, are you gonna like if let's say for example if someone have 68 or 66 that is shown on their Canvas account, is that like considered as a passing grade or that's felony
Okay.
grade? Because
So the syllabus shows 37.5%, as the overall, how much point you have earned as opposed to how many points are possible. So anyone that has 37.5%, is a C or better. That is correct.
okay, so for example, if anyone have 66%, that's what is showing their Canvas account right now. That's when it's passing the class as of right now.
That is only based on what I have graded and what Canvas has recorded up to this point. Yes.
Okay, okay, all right. I just want to get clarifying on that because
Yeah,
I know
sure.
I never get to used to like the 37.5 or not because we always been seeing better. That's the passing grade. This is like kind of my first semester, so I just want to be aware of how like the grading process, so I know not to miss anything or
Yep.
make any mistake during the road.
It's good to double check. That's good. That is good.
Thank you. Thank
Yeah,
you for your clarification. I really appreciate it.
no problem. All right. So it looks like it is time for us to start. It is 5:30 p.m. So are there any further questions, related to what Barak has mentioned? Okay, apparently not. And I'm catching up on the text channel right now. Um, okay, so it looks like everything is okay. All right, so I think Paul, are you good now? I mean, is your audio okay now? Okay, excellent. Thank you. All right, so we are going to spend today, for the most part, talking about the practice exam, and we do have a lab today because we are still behind in terms of lab, so I don't want the lab to be way too behind in terms of the lecture. But we are going to focus on the exam first. Okay, so the exam is going to be about the same in terms of the instructions. I'm not really sure about the questions because I have not made the questions yet. So I can only show you what I did last semester. So every single exam is going to be individualized. So that's why you see your student ID, on the exam itself. The exam is an individual exam, so I don't want to find anyone collaborating, and I do have ways to find. So, for the most part, when people don't, collaborate and, do things they're not supposed to, hey, no problem. Online and offline resources can be used as long as there's no interaction or collaboration involved. So that means you can read the notes, open book, open notes, man. You can even Google, okay, as long as you're not interacting with someone in real time and you're not collaborating with someone in real time during the exam, you'll be okay. So, are there any questions about that really general rule? Because I can clarify if there's any. Looking at the text channel and there's doesn't seem to be any questions. All right, moving on. Oh, okay. Here's
So, sir,
Yeah. Go ahead.
so basically just treat it like an exam that we would if we were on campus.
Yes. Yes, that is a very good way to summarize it. Um, yeah, because I really believe in exams being individual and not based on teamwork. I have taught classes, that are based on teamwork, and man, that was hard to grade, especially when there are teams when you have someone who's actually carrying the weight of the entire team, and there are people who are just basically dead weight in the team. Terrible, just terrible in terms of how to grade. Okay, Curtis has a question. We can have tabs open and won't be penalized. Yes, that is correct. As long as those tabs do not involve live interaction nor collaboration. You can have as many tabs as you want. I'm not going to use Proctorial or anything like that for a few reasons. One, I think when you are at work as a developer, as a software engineer, or as a computer scientist, it is unreasonable to assume that you would not have access to the internet. Okay, so there's that. As opposed to when you're a surgeon, okay, you're performing surgery, you cannot have a nurse and go like iPad and then try to click on something to find out which artery to clip, you know, before you cut something. I mean, that would not be reasonable, right? I mean, so that's why if you want to become a surgeon, I think it's reasonable that to expect you to have memorized everything, right? Because you can't really look up things while you're midway through surgery. But when you're in computer science, when you're developing a program, you can typically look up things. Now, someone is going to ask right away and say, but when we're at work, we can collaborate, we can work with somebody else, we can ask questions interactively. How come we cannot do it here in an exam? Well, that's because I have to give you a grade, and that grade is yours and yours alone. That is the reason why in exams I have to make sure that there's no collaboration. So there's that. Unless the entire class wants to share one single grade, and that fact is known to universities that you want to transfer, which basically means they're not going to let you transfer this class because universities also expect your grade to be individual. So there we go. Grading is based on explanation and steps, demonstration of understanding of knowledge and problem solving skills, and not on just the final answer. So if somebody were to give me the perfect final answer on these questions, but does not show any steps leading to the final answer, that answer will get either no points whatsoever or will get a very low amount of points. So I just want to make it very clear that that is the case because I want to see that you know how to solve the problem and not just the final answer itself. Write your answer in this document right after each question. Now, I can't do that because this is a PDF, which is the document that I shared with you. But in the exam on Wednesday, I am going to give you a Google Doc. So as long as you know how to use a Google Doc, you will just basically be interleaving your answer with the questions. And there are designated places where you insert your answer. I'll show you in just a little bit. Do your text editing in document. Do not copy and paste from an outside source. Okay, that's my typo here. It's supposed to be outside, not output. So that means I don't want people to be editing the document in Microsoft Word or something that is offline and copy and paste the entire document back into Google Doc. Do all the editing in document. For those people who prefer to
By the way, Elsie,
handwrite
can we
and
stop her
use
lunch? Doesn't know what her lunch. She only came over here with lunch.
So someone may
Really?
need to
Yeah,
mute
and
the
then we went
mic.
to Father's Day so twice.
I thought it was more.
No, I went to.
Athena, your mic's unmuted.
Like, she literally came here for 5 minutes after we dropped off the things for Father's Day. And then we went to Father's Day. And then I went swimming with them.
I can
And
probably.
then she came by to get the key twice.
But you saw him at least like 4 or 5 times.
Yeah, but they like literally real quick to get the key
Okay,
to drop
I'm
it. That was
going to be
I'm saying, like,
muting you,
I
Sina.
think you have removed your phone.
There we go. Okay. Am I muting it for the whole class or am I just muting it for myself?
Seems to be.
I can't hear him anymore.
Okay. Sina, if you need me to unmute you, just let me know because your mic was on and everybody could hear your conversation in the background. So the reason it was not to make sure that you cannot talk to the class. It's just that we just don't want to have too much distraction. That's all. All right. So getting back to here. So do all your editing in the document, and if you need to write anything, you can go ahead and handwrite on a piece of paper or on the tablet, and then you can copy and paste the content back into the Google Doc. Now, but if you do that, okay, you need to account for the amount of time that it's going to take in order to copy and paste from your tablet or a piece of paper into Google Doc. So there won't be any extra time allocated for people who prefer to do it on a piece of paper or a tablet. You can indeed copy and paste you can also copy and paste within the document. So if there's a section of text that you go like, I just have to write exactly the same thing, you can just copy and paste from within the document. So that part is okay. There are 8 questions. There were 8 questions in the previous exam one. I have not decided how many questions for this particular exam. So so a lot of things may not be the same, but I'm just going to give you what I did last semester. All right, so here's question number one. Here's question number 1 of 8. I'm not sure whether you guys want me to work from the bottom up or from top down. So do you want me to work from question number 1 to question number 8, or do you want me to work from question 8 back to number 1?
Top down.
1
would
to
be
8
better.
sounds good.
1 to 8? Top down. Okay, that's what I heard consistently. All right. Okay, I saw a question. The question was, can that person write the answer on an iPad and submit all as a PDF file? The answer is, I will only use the Google Doc for grading purposes. So if I don't see it on the Google Doc, I am not going to grade it. For a few reasons. One is, I tend to lose track of things. So when people send me some document using Gmail, it might get lost. But if it's on the Google Doc, and I organize all of the questions, all the answers within the same folder, that's easier for me to keep track of things. So the answer is, you just have to make sure your answer is on the Google Doc. All right. So I think I hope I answered that question, for that particular person. All right. So getting back to question number 1 of 8. So number 1 and number 2 are the hardest because there are only 4 known bits among all of these individual bits. So if you count the number of bits, okay, so X, Y, Q, and S, they all have 3 bits each, and then K has 4 bits, and then on top of that we have the overflow and the L bit. So there's a total of, let's see, so 1, 2, 3, 4, 5, 6. So there's a total of 18 bits, and you're only given 4 in this case. But I promise you, everything is resolvable in a deterministic way, which means there's no place here where you can go like, no, this one can be a 0, it can be a 1. Nope, they're all either a 1 or a 0, but it has to be just one of them. And I wrote here not to miss the overflow flag because the semester before a bunch of people missed the other flag. So I had to write some additional instructions, just so that people don't miss the overflow, which is an O, and I intentionally use lowercase o in this case so it doesn't get confused with 0. But since I use lowercase, then I'm also going to use lowercase l, which unfortunately does look like a 1 depending on the font. But the font that I use within the question block does not resemble a 1 because a 1 looks like this, and then in lowercase l looks like this. But it is also stated here that's a less than L flag. And overflow is also defined differently for addition, and that's because in subtraction, which is what we have mostly talked about the overflow flag for, and in the semester before, I only talked about overflow in class for subtraction. In this class, I did talk about overflow for addition as well. But it doesn't hurt to redefine it. So the overflow is now redefined like this, whereas MSB is the most significant bit of, and then the L flag L is still defined as overflow exclusive OR with the most significant bit of the sum in this case. So lowercase s is the sum. So I hope that kind of I just want to make sure that everybody understand what is given to you. The bits, some, most are question marks, some are known to be 0 or 1. The equation to find the overflow is over here. The equation to find the L flag is over here. Do we have any questions about this? I'm going back to the text channel and pause. Question is good. Does the L flag does it have any useful interpretation in addition? The answer is no, but it is still there. So since it is still there, I am still gonna be using it as a part of the question. But that's a good question. The answer is no. It does not have any useful interpretation in this context. Other than sometimes it gives you some information that you need in order to figure out the rest of the bits. All right, so let's move on. The first part is to figure out all the unknown bits marked as question marks. The sequence of figuring out the unknown bits must be self-contained in this answer and not reliant on the answer of another question. So what that means is you cannot quote and say, oh, I'm repeating this portion of the answer from an earlier question. So it has to be self-contained, from within this question itself, from your answer to this question. For each bit, clearly state which bit it is, what value you think it is, and how you use the definitions to derive it. So you need to explain to me, why you think a bit is a 1 or 0, and what knowledge did you use from the class. Okay, and knowledge, when I say knowledge, it is really loosely translating to definitions. So you kind of have to know the equations, the definitions, and know how to connect them. Okay, so the tricky part is how to connect the knowledge, because knowledge is, in the modules. Okay, I'm hoping many of you would have compiled your own list of the definitions by now, because that was recommended from early on in this summer session. Let's see, I'm just going to read the rest of this. So k2 equals 1 before ki equals xi exclusive or with qi, and at this point x2 is 1 and q2 is 0. Okay, now when you refer to the definitions, you can always use a shorthand. In other words, you can define it ahead of time and just say refer to definition 1, 2, 3, 4, or A, B, C, D. So this way you don't have to type as much. So there's that. You may update the unknown bits of the addition in place, but the explanation must be sequential. So I need to see how you explain how you got the bits, and that particular order has to be sequential. So I have to know in what order did you resolve the values of the bits. So if the order, in the case of the ordering, does not make sense, points will not be earned. Note that the unknown bits can be from x, y, q, k, s, as well as the overflow and the less than bits. T0 should not be assumed 0. So no, this is copied from an earlier semester. It really should be K0 in this case because we are dealing with addition. So K0 should not be assumed 0 as it is an input pin. And that's because in the semester before, many people just assume in that one, T0 would be 0, and that is not a reasonable assumption. Use this area to explain how you got the unknown bits. Okay, typo here. Resolved. A bullet list makes the answer easy to read. So between here and here is where I want to see the answer. Alright, so let's go ahead and figure out the bits. Okay, so I will try my best to type everything that I would expect from the answer. So you look at this and go like, you scratch your head and go like, where do we start, right? So you only got 4 bits that are known. Okay, this is known right there. This one is known right there, and this one is known right there, and also we have the overflow also known right there. So you have to look at these and think about which one can you possibly start with and be able to work out the rest of the bits, to work out the bits, without any ambiguation. In other words, you have to think about, okay, if I utilize this particular bit, can I lock down, the value of the bits that I'm working with, so that there's no such thing as, a particular bit can be a 1 or a 0. So it might be helpful to recall the rules. Okay, so I'm gonna recall the definitions here. So definition A is just going to be the sum, SI is, SI, the sum bit I is KI exclusive or with QI. That's going to be very helpful at some point. And we also want to look up QI. So QI is XI exclusive or with YI. The carry flag is also going to be important. So in this case, we have KI plus 1, and you don't have to use subscript and stuff like that, as long as the context makes it pretty clear that we are referring to bit I plus 1 of the K row. You don't have to use subscript or the square brackets, because that way you don't have to type as much. Okay, so this one is, since we're dealing with addition, so it's going to be xi and yi, or ki and qi. And that's after we expand the carry function, because the carry function is just conjunction itself in this case. All right, so we got 3 major definitions here. X, Y are given, so is K0, so there's nothing, there are no rules specific to those. So we got the 3 rows that we need to figure out. Those are all the definitions. All right, so if you start with S0, which is the one that is highlighted here, you cannot really quite resolve what X, Y, or K0 should be, because there's a whole lot of combination that can make it happen. And but we do know that K1 is a 1. So maybe between these two we can figure out something. Okay, so that's one way to start. The other way to start is to start with the overflow flag and also K2 in this case, because those two would also lock down all of these bits over here. That's the usual way that I start, but I think we can also start with S0 and also K1. So let's take a look at that. So the way we start is to say S0 is 1, and that is the result of and then you can quote the definition here. Using definition A, that is K0 exclusive or Q0. Okay, and we can just write down which definition we are using here. All right, so that is fact. Okay, S0 is a 1 is a fact. S0 is K0 exclusive or with Q0 is a fact. That is part of the definition. So these you don't have to explain because they are basically just facts, but you do have to write it down because it's the starting point of your reasoning. Okay, so what does that imply? Okay, so here comes the reasoning part, right? So the reasoning part is we know that Q and K have to be different. Okay, so this implies Qi does not equal to Ki. Oh, they're both zeros. Sorry, Q0 does not equal to K0, because when the exclusive OR is a 1, then we know whatever we are exclusive ORing, one has to be true and the other one has to be false. So if you have any questions or if you want me to pause, just let me know, because otherwise I'm just gonna go like that. All right. So knowing that, now we have to ask another question. So we also know at this point that K1 is a 1. So K1 is a 1. That implies, X0, Y0, or K0, Q0 is a 1. Does that make sense? Because K1, according to definition 3, okay, so we'll write down definition C here. So according to definition C, ki plus 1 is defined like this. So when I equals to 0, that defines what k1 is supposed to be, but then we know that the x0 and y0, or k0 and q0 has to be 1, which means one of these has to be true. Okay, one of these two conjunctions have to be true. So now you have to look at this and go like, do we have enough information to lock down the values of x, y, q, and k? I think we do. I think we do. So the way we reason this out, okay, and explain it, okay, is because, okay, q0 and k0 are different. This means x0, y0 being true is the only way to make k1 equals to 1. Okay? So that means, but that further implies x0 is 1, y0 is also 1, which also implies q0 is a 0, which now implies k0 is a 1. So now we have just locked down a few bits, because now we figure out that x0 is a 1, y0 is a 1, q0, because of the definition, has to be a 0, but because the sum bit is a 1, so that means k0 would also have to be a 1. So we got the first column figured out at this point. Yep, and Folin is correct. Folin is correct in the deduction. All right, so I'm going to pause here, okay, and see if there are any questions about the deductions up to this point, or any questions about what kind of reasoning or what kind of knowledge we have used up to this point.
I'm curious if it would be helpful at all to do a substitution.
Do a substitution. Okay, go
Start
ahead.
maybe with A, since we know what S of 0 is, and we can Ki XOR, and then in parentheses, Xi XOR Yi.
Okay,
And
so if I understand you correctly, you are saying that we want to, is it helpful to do something like this? So instead of using q0, you're referring to xi exclusive or with yi. Is that
yeah,
okay?
Yes, and then because it can only be one of those to make, it can only be one of those K0, X0, or Y0 to make S0 1. Or actually, you know what? I guess this would be the next step that we could do.
Yeah,
Since we know.
Yeah, I don't think it's going to be helpful. I don't think it's going to be helpful because you still have to figure out what is q0.
Okay.
Yeah, but but it is important to understand the chain of how to reason. You know, understanding that q0 is how q0 is defined is important.
Okay.
Yep. But if it makes sense to you and you can logically use it to figure out the value of the bits, that's fine too. So I'm not. This is not the only way to explain things. You know, this is just one way of explaining things in a logical way. So I'm not excluding, other possibilities. I'm just saying that this is one way to do it. All right. So now that we have column 0 all figured out, now let's move on to column 1 and see whether we have enough information. Are there any questions? Yeah, the music box thing is from my own phone, so sorry about that. Go ahead.
Oh, it's perfectly fine. I was just wondering, what have we used up to this point, and what sections would they be found in, if you don't mind me asking, just for clarification's sake?
These would be coming from the binary addition module.
Right.
Yeah, all of these definitions come from the binary addition module. The reasoning part may not be coming from that, because the reasoning part is how we utilize the definitions that are defined in that particular module. All right.
All right. So it's application of the theory and the like.
Yes. Yep. Exactly.
All right. Thank you.
And Paul is also correct in the text channel. A clear understanding of this is not multiplication. Instead it is conjunction, and conjunction has priority over disjunction. This is disjunction, and if you see the exclamation point, it is Boolean or logical not. So understanding the notation is also very, very important, especially when not is involved. If not is involved, is not okay. Let me put it. Let me say it again, because it's gonna sound confusing. If the not operator is not involved, in other words, if there's no logical negation, technically speaking, multiplication and addition would also work in this case, even though it was not intended. Okay, but once we have the negation symbol involved, then obviously everything should be Boolean or logical instead of arithmetic. All right, so let's move on to column 1 and see if we can figure out column 1. I haven't tried this way before. I think it may not be possible, but we'll see. Let's see. Yeah, I don't think it is possible to resolve column 1. The reason why it is not possible to resolve column 1 is you cannot use a lower bit to help resolve a higher bit, okay? Because the dependency of the carry kind of works the other way. So knowing the entire column 0 is not going to help us, with column 1. So we only have these 2 bits to work with, if we were to just look at these 2 columns. And that alone is not enough. The overflow bit is actually going to be very helpful, but the overflow bit is only useful when you're dealing with the most significant bit, which is column 2 in this case. So I don't think we can use column 1. We can resolve column 1 at this point. So we'll go ahead and try to resolve column 2 in this case. So when we try to resolve column 2, we have 2 known bits. One is K2, and the other one is overflow O. Using K2, using K2, you're right. Okay, so Paul is right. Okay, using K2, we can actually use. Okay, so I'm gonna separate the section. Thank you, Paul. You're correct about that. I forgot about the power of the carry. Okay, so let's go ahead and see what that means. Okay, because Paul says K2 is the key, so let's figure out what K2 is telling us. So from the question itself, K2 is a 0, okay? And how is K2 defined? It is x1, y1, or k1, q1. Okay, that's just coming from the definition. So we can just quote definition C in this case, because it's coming from here. Now, if this is 0, so that means x1, y1 is, okay, so this implies x1, y1 is 0, and k1, q1 is also 0. Now, it doesn't mean x1 and y1 are both zeros. It simply means that at least one of them has to be a 0. And also between k1 and q1, one of them has to be 0 because the conjunction is a 0. Now, this is where reasoning comes in, okay? Reasoning comes in when we say, but k1 is known to be a 1, right? So this implies q1 has to be a 0. Okay, let me just pause and make sure that everybody understands why I can lock down the value of q1 right now. It is because starting with k2 being 0, we can imply that k1 and q1 is a 0. But the question actually tells us that k1 is a 1. So when you look at k1 and q1 being false, and k1 is true already, so the only way for this to happen is q1 being false. And that's why we can now conclude that q1 is false. q1 is false implies the exclusive OR between x and y also needs to be false. So this implies x1 exclusive OR with y1 is 0. Okay. So if x1 and y1 are 0, that means x1 and y1, they have to be exactly the same value. They're both true or they're both false. Since k2 is 0, because that is known to us, okay, that is just given to us, and since k2 is a 0, and k2 is already predefined here, we know that x1, y1 is false, and that which then implies x1 is false and y1 is also false. Okay, so let me just pause and make sure that everybody understand the line of reasoning here.
I got it, Professor. I just have a quick question.
Yeah, go ahead.
It logically, it can't. We know we have something wrong if they're either both true or both false in the K2 definition. Like if we get x1 y1 is false and k1 q1 is false, we know we have a problem. Correct?
That can happen because right now that actually just happened, right? Because in order for k2 to be false, which is given to you, x1 and y1 has to be false. K1 and q1 also has to be false because they are ORed together.
Okay, and that's not an exclusive OR, so they can both be true. Or by definition, K1. I'm sorry.
That case does not happen, right? Because we already illustrated in class, that these two conditions, let me make it clear which two. Okay, so I'm gonna space these out like that. So this condition versus this condition, they cannot both be true.
Okay.
At the most, one of them can be true, but they cannot both be true, and that's the reason why we can use a logical OR in place of an arithmetic addition.
Got it. Thank you.
Very good. So now, just to add to the confusion, okay, hopefully that is not the case, but it's possible. But because it is not possible that x1 and y1 is true and k1 and q1 is also true, that means whatever operator we choose in between here, now we have three choices. We have the arithmetic addition, we have the logical OR, but we can also use logical exclusive OR because that case does not happen. It is not a concern to us. But I'm just not going to mention exclusive OR in this context anymore, just to make sure that there's no further confusion. All right.
And
yeah, go ahead.
If you don't mind me asking, why can't x1, y1, or k1, q1 both be true? Why does one of them have to be false? And if that's the case, can both of them be false?
They can both be false. That is not a problem. They just cannot both be true because of the q1, because of the relationship between the q and the xy bits. Because q is the exclusive OR, which means if x1, y1 are both ones, then q1 has to be a 0. If q1 is a 0, then k1, q1 is guaranteed a 0 as well.
I'm sorry, I'm not really understanding what that means. I'm sorry, sir.
All right, so I'm going to try the next minute to try to explain this because it was explained before, and I actually expanded this quite a bit, in the before version. All right, so k2 is a 0, x1, y1, or k1. Now q1 is defined as x1 exclusive or with y1. So when this is 0, we know that x1, y1. Okay, so this implies x1. Okay, let me see how should I do this, because this has nothing to do with this specific part of the question. It really has to do with only definition C. So with definition C, ki plus 1 is xi yi which means xi and yi, or ki and qi. But qi is defined earlier according to definition B as xi exclusive or yi. Okay. So we're going to say if, and I put it in all caps just to make sure that people understand that this is just one scenario that we're looking at. So if xi and yi is a 1, then xi exclusive or with yi has to be 0, because the only time you have a conjunction being true is when all the participants of the conjunction are true. So when xi, yi are both 1s, then the exclusive or between those two are guaranteed to be 0. Then this also implies ki and xi exclusive or with yi is also going to be a 0, because it is a conjunction here. So if xi exclusive or with yi is false, then the conjunction of that and ki, whatever ki is, does not matter anymore. The conjunction also has to be 0. I'm done with the explanation. And does that work?
I think so. Yeah.
Okay. So if you're not 100% sure, then you might want to highlight this, and kind of go back and review this part of the explanation and see if you can, convince yourself that they cannot both be true. That was also discussed when we got to binary addition, so re-watching a part of that lecture may be helpful as well. All right, so we got column 0 done, we got column 1 done. Let's go to column 2. So column 2, is doable, and the biggest help to resolving column 2 comes from the overflow flag. So now I'm just going to quote the overflow flag, and I'll add this to definition D. Okay, D, F, and D. So the overflow is defined to be, I'm going to use the exact bits in this case. So that is defined to be x2 and y2 and not s2, or not x2, not y2, and s2 over here. So I'm just repeating the definition. There's a question. I don't think. Oh, S1. Oh, right. Okay, thank you. So I forgot to write down S1. And since we know Q and K, so K1 is 1 and Q1 is 0, implies S1 is 1. And this is based on definition A, because that defines how the sum bit relate to the K and the Q bits of the same column. Thank you, Paul. Okay, all right. So now we can finally move on to column 2. So with column 2, overflow is going to be very helpful, because we know the overflow is a 1, and this is what I mean by in document copy and paste, because hey, why not? So we know that this is a 1, okay, because we know that the overflow bit is a 1, so that means this expression is a 1. Okay, so what does that mean? Now this is there are two conjunctions here. There's this conjunction and there's the other conjunction. The two conjunctions cannot both be true at the same time, because in order for one to be true, it automatically makes the other one not true. So they can only up to one can be true at any time. They can both be false. That is not a problem, but they cannot both be true. So now we have to look at this and go like, okay, but which one is it, right? So now we implies x2, y2, not s1 is true, or not x2 and not y2 and s2 is true. So now we just have to eliminate one of them and see which one makes more sense. So now we go like K2 is once again going to be useful. So K2 being a 0 is helpful. Let me see. Okay, so let's figure out which one it is. Okay, so we can now say if x2, y2, not s2 is true. I keep having a typo here. Okay, so then we know q2 is a 0 because let's see, because I'm just trying to quote the definition here. So q is in definition B because of definition B. There we go. Okay. Then we also know something that is not supposed to happen, right? Because when this is the case, then S2 is also going to be a 0 because of DEFN A. In this case, oh, that is what we want, right? Yep, okay. So that is consistent within itself. Okay, so within the assumption. Okay, so based on the assumption, consistent with the assumptions. So now we look at the other one because we know one of them has to be false. So we do have to want to see how it can be false. So on the other hand, if we say the other part, okay, which is this part here, is true, then what's going to happen? So in this case, then Q2 is also going to be false because of definition B. Let's see. Yep, okay. Then S2. So S2 is still going to be false because of definition A, and that is inconsistent with the assumptions. Because not x2, not y2, s2, oops, being true implies s2 is true. There we go. So now we can rule out this one because it causes a contradiction. Okay, I'm going to pause here and see if there are questions about why we can lock down only one of the two conjunctions being true in this case. Particularly why the second one, how we can rule out the case where x2 is a 0, y2 is a 0, and then s2 is a 1.
How can we rule it out?
Okay, because I'm gonna sound like a broken record here, but you can tell me when you're not making that association. Okay, so if this conjunction is true, then what we know is x2 has to be false, y2 has to be false, and s2 has to be true, because these are the three components of the conjunction, because there are three components in the conjunction. So in order for the entire conjunction to be true, each component has to be true. Is that okay?
All right, that sounds good.
Okay. So if that is the case, okay, if x2 and y2 are both false, and in fact, if they are the same, okay, if they're both the same, then q2 is going to be false because q2 is the exclusive OR between x2 and y2. Is that okay? That's from definition B up here.
All right.
Okay. And once we know q2 is false, right? Okay, we just hypothetically solve q2 being false, and we know k2 is false to begin with because that's given in the question. That means s2 is also false because of definition A. Definition A tells us that the sum bit is the exclusive OR between the K and the Q. Is that okay?
I'd say so, yeah, that's okay.
But now we have a problem because that conclusion of S2 being false is contradicting the fact that this entire is contradicting with the assumption that this conjunction itself is true. Because if this conjunction is true, then S2 has to be true, but we also make a conclusion that S2 is false because of definition B. So that means this assumption cannot be true because it leads to a contradiction within itself. So basically we're using implication, we're using deduction, where one branch of the deduction says S2 has to be a 1 because of how we define the overflow, and then the other branch of the deduction, which is based on how we define the sum bit based on the Q, using the Q and the K bit, concludes that the sum bit has to be a 0. A bit cannot be both a 0 and a 1 at the same time, and as a result, we basically say this assumption cannot be true because it leads to a contradiction. Whereas the other assumption, which is this one, did not lead to a contradiction. So we go with the other one. We go with the one that is highlighted here. All right. All right, so let me take a look at the text channel. Yes, that is correct. So I'm saying yes to what Fulin wrote in the text channel. Okay, so let me just insert one more thing here. Okay, we'll just say one more thing. Then x2 is false, y2 is false, and s2 is true. There we go. So now we have a more complete line of reasoning here. There we go. So does that work? This is logic. This has almost nothing to do with this class. Has nothing to do with gates. Has nothing to do with, yeah. But it does have everything to do with being a effective developer, programmer, or software engineer, because this is basically how we troubleshoot.
Professor,
Why are we covering it if it doesn't have anything to do with this class?
Because this is still related to programming. I mean, if you cannot do this, I would say, I mean, this is still based on what we know from CISP360, right? Because it only relies on conjunction, disjunction, negation, and it also adds on top of that what is specific to this class, how the carry bit is defined, how the sum bit is defined, which has to do with binary representation, because we have to use binary addition, inside the machine. So from that perspective, it does relate to this class.
I have a question.
Yes.
Professor. So how did we conclude that Q2 is 0 in the first assumption?
In the first assumption, okay, well,
yeah,
so let me see if I add this. So then x2 is 1, y2 is 1, and s2 is 0. Does that make it more clear?
So now the Q2 is 0 because both x2 and y2 are the same.
Because of definition B.
Definition B.
Yes.
Yeah, the x2.
Yes. So the whole thing hinges on how we define the overflow bit, because the overflow bit, gives you basically it's a disjunction of two conjunctions, and when one of the conjunctions, can be true, then we look at conjunction. When a conjunction is true, it tells you a lot because it tells you every single component of the conjunction has to be true. Similarly, if a disjunction is false, it also tells you every single component of the disjunction has to be false, which is equally powerful when it comes to locking down values of stuff. So in this case, because the disjunction is a 1, we can't really use it to tell us a whole lot. But because we know one of the conjunction has to be true, that tells us a lot. So this is basically how we look at the given bits and then go back and resolve the bits that are unknown. Because at this point, because once we confirm this is the case, we can now figure out what the sum bit is. Well, actually it is here already. The sum bit is already concluded that it is a 0, but we also conclude Q2 is a 0. So now column 2 is completely resolved. Are there any questions? No questions? All right, so we only got one. Yeah, go ahead.
How did your previous class do with this exam?
Not very well.
How many, what percentage would you give it?
I cannot remember. But I really think that this is, it's a matter of how. Okay, remember, the more I explain this, the better I can explain this too. So you guys are benefiting from the previous 2 semesters of students, and I now understand what they were not understanding. So I'm explaining this in a different way to hopefully help you guys connect the reasoning of all of these parts. So K3. So we'll work out K3 and then we can look at another example. Or if depending on what kind of questions you have, I can try to answer those questions too. So what about K3? Well, using whatever definition of K, so definition C, that is dependent on the addition of x2, y2, or the q2, k2. So we know that x2, y2 are both 1s, so k3 has to be a 1. So k3 is a 1 because x2 is 1 and y2 is 1. And also, don't forget the definition of the carry bit, which is definition C. There we go. So now we have a complete answer to the first part of question number 1. All right, so let me ask you guys this, okay? Because it seemed to me that some of you are implying that this kind of question is difficult. So let me ask you, why is it difficult? Because it was not my intention to make things, like supremely difficult, but yeah, go ahead.
Do you want me to go first, or do you want to go first?
Jump in. Go ahead. I'll go next.
I guess it's just I don't really have a fundamental understanding of this. It's just very confusing looking at it, and it makes it very difficult for me to rationalize how this makes sense besides just parroting the formula that's been given. I don't really have a connection to what's being said, and it's very hard to make a connection, I suppose. Is one of my biggest problems with these sorts of problems. And it's more of I suppose, a personal problem, and I just need to get more acclimated to it and just have it make sense, like you said, make it make sense to yourself. Okay. But that's mainly what's been hitting me.
Okay, well, thank you for that input. I'll try to think about something to help you guys kind of not so much to practice, because this really has very little to do with practicing. It has more to do with how do we connect the pieces. Like, what are the equations relating, between the components, and how knowing one particular bit value will help us illuminate some of the possibilities of some of the other bits. So it has to do with that too. Okay, go ahead, because I know somebody else also wants to make a point.
Yeah, and I think this point helped me. Just really nailing down an understanding of the basic like what you mean when you say exclusive or.
Mm-hmm.
That's obviously fundamental, and that seems obvious to you. But it took me, at least, I don't know if I could speak for anybody else, but it took me just another. I had to circle back to that, but now it makes sense. But I'm just saying, like, being really clear about the definitions of the terms you're using is important for succeeding.
Right. Okay. Well, that's good. It's good to know it now instead of on Thursday, because now you can start to relate all of the concepts together, and so on Wednesday, that becomes a little bit easier like that. So I'm just giving you the truth table of exclusive OR. It looks exactly like regular OR, except for when both x and y are both true, then the exclusive OR is going to be false. And I'm looking at the comment. To that question, I get that last semester, and my answer was just try to do as much as you can. So when you think about the strategy, I will tell you, what questions are easier and what questions are harder, and I will probably not give them equal weight, this time around, although I haven't really figured out the weight, of how to differentiate between the questions. So I might, make it so that, you can answer, like all. I'm just giving you an example here, okay? A possibility, which doesn't mean this is exactly what's going to happen on Wednesday, but I might make it so that if you answer the last 4 questions, it would be equivalent to answering the first 2 questions, or equivalent to answering the next 3 questions, or something along that line. So you have the option of not answering every single question. You just have to kind of decide for yourself, how do you want to do it? Okay, do you want to start with the easy ones and try to answer as many of the easy ones, but then you have to answer more of them, or do you want to start with the more difficult one where you only have to answer like 2, but then they're more difficult to answer? So I'm kind of playing with that idea in my head. Haven't quite decided yet. I really don't think. I think this is a matter of really just relating the concepts, okay? Just looking at the definitions and understanding, because there are only 3 or 4 definitions in use here, including the overflow. There are only 4 definitions in use here. In some of the other questions, there's also a definition E, which is really simple. That is the L flag. The L flag is, in this case, S2 exclusive OR with the O flag. And that's it, okay? You're looking at 5 definitions. And the question is, how do you make use of these 5 definitions and what you already know about Boolean operation to help you lock down the value of individual bits? So before someone is going to say, but this has nothing to do with programming, I beg to differ, okay? Because this has everything to do with programming and being an effective programmer too. Because when you're debugging, you're looking at something like this. Okay, you're not seeing a whole picture when your program crashes. It will give you a symptom, like certain things are known by the time it crashes, but many things are unknown. So the question is, how do you find the bug? How do you quote unquote reverse the execution of a program to find out exactly when the program went wrong? That is using the same kind of reasoning. Okay, a lot of times it's the same kind of reasoning. You're trying to rule out possibilities, and sometimes you cannot rule out all possibilities, where you have to design an experiment to intentionally feed the program a particular type of input to help you differentiate where the bug is. But this really still is just application of logic, which is essential to programming. Doesn't matter whether you want to become a computer scientist, computer engineer, electrical engineer, you will still need this type of reasoning. All right. Shall we move on, or? Okay, I'm going to move on. So we'll move on to the second part. The second part is to figure out the values being represented. So what is the signed, unsigned interpretation of x, signed interpretation of x, and so on? That would be the easy part, because once we figure out the x1, x2, x1, x0, x1, x2, y0, y1, y2, then you just apply the sigma notation. There are two sigma notations, one for signed and one for unsigned. Apply those for base 2, and you're done with part 2. So part 2 should be pretty easy. And then we have part 3. Part 3 is you know how to compute K3 using the following steps. So what is the multi-bit P terms? In other words, if P2 is a 1, P1 is a 1, and P0 is a 0, this is how you write out the P term as one single bit pattern. So in this case, you just have to remember how P and G are defined. So does anyone want to remind me how P and G are defined when we worked with the carry look-ahead adder?
G is equal to xi, yi, and p is equal to xi or yi.
Yep, that's right. Okay, so that's that should. So once you know the x and the y, the p and the g are fairly easy to work with. So the more difficult part is K3. So when you look at K3, you can go back to the notes, because in the notes there is the equation of K3 defined using the PG terms and also K0. So from that, you can also make a conclusion of what K3 is supposed to be, and that should be consistent with your answer to K3 over here. But that part, the third part, is here so that I can see that you know how to use the carry look ahead mechanism to figure out the carry bit of bit 3. So Eric is correct in the text channel. But remember, in subtraction, they are different. Oh, this is also something that happened last semester, and I can tell you this, okay? And I can tell you this so that you guys would not make the same mistake. Is sometimes I use addition and other times I use subtraction. So you have to read the question carefully and know which one I'm asking. Because depending on whether it's an addition or subtraction, a few things are defined differently. So just be careful. And I promise you I will not be intermixing addition and subtraction between the questions. So if they're either all additions or they're going to be all subtractions. All right, so let's work with question number 2 of 8. Okay, so these two are the hardest because these two only have 4 bits that are known to you. And this time, I'm giving you, out of the 4 bits that are known, 2 are flags. And 2 are, basically from X. So let's see what we can do with this one. So I'm going to write down here. This is for question number 2. So for question number 2, it does not seem to make sense to me to start with column 0 because there are not enough information to lock down column 0. Even if you were to use the 1 in column 1, column 1 is not going to be useful either. So in this case, I'm just going to tell you guys, okay, the overflow is very useful. So if the overflow flag is known to begin with, you probably want to start with it because it locks down a few bits at the same time. All right, so we're going to start with overflow. Okay, so overflow being a 1, and that 1 is x2 and y2 and not s2, or not x2 and not y2 and s2. You can also just quote the definition from up here. Okay, so now that implies one of these two is true. Okay, so it implies this particular conjunction is true. Okay, or this conjunction is true. In other words, I'm using the same reasoning as last time. So if you had a label earlier, you can basically just refer to that label. When you just want to let me know that one of these two conjunctions is true. All right, so we're gonna say what if, okay, this one is true. So you kind of have to evaluate both of those. Okay. Then x2 is a 1, y2 is a 1, and s2 is a 0. Okay. So you look at this and go like, do we have a problem with this? Well, let's find out. Okay. So from the O and the L bit, if both of these are known, can we use that to infer something else? Okay, so I'm going to put it right here. So I'm going to say O being 1 and L being 1. Does that help me deduce one other bit?
Yes, S2 is 0.
Aha, okay. So S2 is a 0, and that is because of what?
The exclusive OR.
So when we refer to the definition, it's going to be definition E, right?
Mm-hmm.
Yep. So gotta write down it's because of definition E, because definition E spells out that the the L flag is the exclusive OR between the overflow and S2, and because we know the overflow is a 1, the S2 has to be different, so it has to be a 0 in this case. Okay, so this is consistent with S2 that is known already. Now, what about the other one? Now, in the test, if you find the one that is consistent, you just have to illustrate how it is consistent, but you don't have to explain why the other one is not consistent. But since I'm explaining, the process, I'm going to have to show you why the other one is not going to have consistency. Because in this case, we can tell that x2 is a 0, y2 is a 0, and s2 is a 1. This contradicts with S2 being 0 from earlier. Does that make sense? So we know this cannot be the case. Okay, this cannot be the case. This has to be the case. All right. So now that we know this has to be the case, that would further imply Q2 to be a 0. And because we know Q2 is a 0, we know S2 is also a 0. That also, okay, now we have to say because of definition B, that would also further imply, let's see, K2. All right, so I'm gonna let you guys try to figure this out. What about K2? We now know what is S2. We now know what is Q2. So what about K2?
Should be 0 as well.
It has to be 0 too. Yep. And which rule are we using this time?
This is B, definition B.
Definition, not B.
Oh, so D?
No. We
A.
used definition A already. Yeah, we used definition E
No.
much earlier. This is definition A because we know SI already, and we also know QI already at this point. So we know SI is a 0. We know QI is a 0. So the only thing you can exclusive or with 0 to get a 0 is 0 itself. So that's why we can conclude that K2 is also a 0. So this is from definition A. So now we have completely resolved column 2. Let's do K3, okay? Because once we resolve column 2, K3 is easy to resolve. So what do you think is K3? Okay, look at this part here. So what do you think? Yep, K3 has to be 1 because of definition. Okay, which definition are we using? There are only 2 definitions involving K. One is definition A, one is definition C. So the answer is right. Okay, so Alex is correct. It is definition C. All right, so how is that going to help us to resolve the rest? It actually helps a lot, because now that we know K2 is a 0, we can now work out a lot of the other bits. Okay, so we know that K2 is a 0, and now we can use it implies x1 y1 or q1 k1 is also a 0, and that's because of, okay, this is from definition, I should have memorized these definitions already by now. This is from definition C. So what is the first thing that you can conclude like right away? Okay, yep, okay. So this implies y1 is a 0 because x1 is a 1 already. So this time you don't have to quote a definition, because this conclusion has to do with conjunction itself. Because when we know x1 is a 1 and we have a conjunction between x1 and y1 and the conjunction is false, that means y1 has to be false. Okay? All right. So knowing that will also help us resolve q1. So q1 has to be what?
Zero.
No. So in this case, knowing it is not 0 means it has to be a 1. And that this one is because of one of the definitions, because q is dependent on x and y. So we're using definition B in this case. All right. Now, what can we tell about K1? So think about what K1 needs to be. We know Q1 is a 1 already, but we also know K2 is a 0. So K1 has to be a 0. Okay, very good. Because of definition C. It's because of definition C because we know that K2 is a 0. We also know Q1 is a 1. So if K1 was also a 1, then we would have a conflict of K2 being a 0 as derived earlier. Okay. So now we can, there's only one more bit for this column. So what about S1? We already know what is Q and what is K. What do you think is S? Yep, has to be 1. And it is coming from which definition? It's coming from definition A, which is the only one that that has anything to do with the general bit of the sum. Okay, so it's definition A in this case. All right, so one more column to go, just column 0. So with column 0, where do we start? So where we start is K1. Let's see what K1 is telling us. So we already know what K1 is supposed to be. K1 is a 0. Okay, and that is the conjunction of x0, y0, or the conjunction between q0, k0. So this implies x0, y0 is a 0, and it also implies q0, k0 is a 0. So now, what is that further implying? We know one of the two, right? Between x0, y0, we know one is a 1 already. So what do you think is, what can we infer right now? What is the next bit that I can infer? Y0, very good. So y0 is 0 because x0, y0 is a 0, and also because we are given that x0 is a 1 to begin with, because it is written here. Okay. All right, so knowing what x and y both are, what do we know about q? What is q0? We know x, we know y, so x q has to be, all right, hold on a second. Okay, x is a 1, y is a 0, so the exclusive OR is a 1. So this is because of definition, let's see, definition B. All right. And at this point, what else can we know? Because we just figure out what is x, what is y, what is q, and can we lock down the k at this point? In other words, out of the two possibility for k0, can we lock down which one it is going to be? The answer is yes, we can. Okay, so now the question is why, right? How do we know that k0 is a 0? So remember, in the exam, you have to write down the reasoning. Why do we know k0 is a 0? So k0 is a 0 because of definition, let's see, definition C, and k1 is known to be a 0 to begin with. Because if k0 was a 1, then we would end up with k1 being a 1, which is a contradiction of what we have already figured out. So now that we know q0, k0, what is s and 0?
So how is that line is right? True.
Say that one
The
more time.
line that says k1 is 0, x0, y0 plus q0, k0, that line. If k1 is 0, how is one of the terms is 1? Isn't that or?
Wait, hold on a second here. Say that one more time.
Talking
you
about
mean here?
Yeah.
It's fine.
Okay, that. Let me double check. Yep. Okay. Thank you. You're referring to this bit, right?
Yeah.
Okay. Thank you. You are correct. Okay. So now that we know what is Q and what is K for column 0, what is S for that same column? We're not gonna do row tonight, but we do have a lab. But we'll figure out what is S right now. Once we know X, Y, Q, K, the S is going to be a 1 in this case, and that is coming from definition A. And that's it. So now we have just figured out all the bits. Alrighty. So I'm gonna suspend discussion of the practice exam for now, and instead I will go to the lab so that you have the lab open for tonight. We can potentially use. Go ahead.
So it took, what is that, an hour and 20 minutes to go over. That was still the first question, right?
We are on the second question.
Okay, my bad. All of the first and part of the second question. And how long are we getting to do 8 questions, or how long did your last class get to do 8 questions?
They got 80 minutes.
Okay. So about the same length of time. So do you see like why I'm concerned about our ability to actually finish the entire thing, or even get a half decent grade on the exam, considering the timetable right now?
Well, that's also why I said that there's a possibility that I will grade this so that I can group certain questions together. Like you can answer the first 2, 3 of the next 3, or 4 of the next 4. And so basically the first 2 will carry the same weight, and they add up to the total score of the entire exam. The next 3 will also carry the same. Each question carry the same weight within those 3, and they also add up to the full score of the exam. And then the last 4 are the same. Okay, those 4 questions carry the same weight, and they also add up to the full score of the entire exam. So you guys can then choose, right? I mean, whether to do the first 2, the next 3, or the last 4. I'm contemplating.
Only do the last 4, and we got 100%. We would get 100% on the total exam score.
That is what I'm contemplating. Yes. but no promises right now. Yep. All right, so double is the access code to this particular lab. And since I started this a little bit late, I'll give you guys like 5 more minutes. Not a problem. June 21st, 8:20 p.m. Oh, 8:25. I just said give you guys 5 more minutes. There we go. And save and publish. There we go. All right. So the next, if we were to go back to the practice exam, the next few questions are easier because there are more known bits. So with question 3 and 4, there are 6 known bits, and then with the last 4 questions, there are 8 known bits. So they are considerably easier to work with because of the number of known bits in these cases. So that's why I said if I'm contemplating the idea of separating the questions into different groups. So within the same group, they would carry the full weight of the entire exam. What I don't want to hear people complaining about in that case is, well, I tried the first question and then I decided that's too hard, and then I move on to the next group of questions and I tried the first one and that was still too hard, and then move on to the last one and then I ran out of time. I can't really say anything about that, okay? Because if you choose one group, then you're gonna have to kind of stick with that group, because I'm just gonna have to grade based on which group people have chosen to answer if I go with that option. All right, so let's do the lab for now. I'm going to go away for about 10 minutes and then I'll be back to answer questions. If you have any questions about the exam, I will try to answer those questions first also, but I'll be answering the lab questions first because that's due at 8:20 p.m. 8:25 p.m. Sorry. There we go. All right.
Can you put up your the text document that you just had on the screen for a second? I didn't catch the last part of it.
You mean this one?
Yeah. I just wanted to screenshot it so I could see it.
Hold on a second. There we go. That the whole thing is now on Discord.
Oh, okay.
I just copied and pasted the content onto Discord.
Cool, thank you.
All right. Anything else? Yes, the exam is Wednesday at 5:30 p.m. So we'll start at exactly 5:30 p.m. on Wednesday. Alrighty. Okay, so if there are no further questions, I am going to stop streaming and also stop